In the last unit, we learned that an ionic bond leads to the formation of what's called an ionic compound. In this section, we're going to look at the different types of compounds that are formed when a covalent bond is created. So there's two main types of compounds that are formed when a covalent bond is created. The first type is what's called a molecular compound. So examples of molecular compounds include water, carbon dioxide. The other type is what's called a covalent network compound. Examples would be a diamond, graphite, silicon dioxide, but these two types of compounds can be created when a covalent bond is formed. So a key skill moving forward is when you're given the formula of something, you should be able to identify if it's ionic, molecular, or covalent network. So in the last unit, we looked at to identify something as being ionic, it could be a metal-nonmetal combination like magnesium oxide, a metal polyatomic ion combination like sodium hydroxide, a polyatomic ion nonmetal combination like ammonium chloride, or a polyatomic ion plus a polyatomic ion like ammonium carbonate. Now we need to add molecular compounds and covalent network compounds as well. So a molecular compound is just going to be made up of nonmetals. So for example, diatomic nitrogen, N2, carbon dioxide, CO2, water, H2O, they're all examples of molecular compounds. Whereas a covalent network compound is either made up of pure carbon, sometimes that's called elemental carbon. It's when carbon is just by itself. And what you're going to see is you'll see carbon's symbol, and next to it in parentheses, it's going to talk about what type of format it's in, either C diamond or C graphite. The other thing that you can look for to identify something as being a covalent network compound is if the compound has a metalloid in it. So silicon, germanium are both metalloids. If a compound has a metalloid in it, you can classify it as being a covalent network compound as well. So what I want you to do is go through and look at these formulas and identify the type of species. Is it an ionic compound, covalent network, or molecular? So that first one is going to be covalent network. It has germanium in it. Germanium is a metalloid. The next one is ionic. It's a metal-nonmetal combination. The next one is covalent network. Is that pure carbon, or we could say elemental carbon, where it's carbon that's by itself. So just because something has carbon in it, it's not going to make it covalent network. The carbon has to be by itself. It's either going to say C diamond or C graphite. The next one is molecular. It's just nonmetals. We have covalent network. Silicon is a metalloid. And then that last one is molecular. It's just made up of nonmetals. So a key skill moving forward is when you're given a formula of something, you should be able to identify it as being either ionic, molecular, or covalent network. All right, so what we're going to look at are the properties of covalent network and molecular compounds. So in the last unit, we established the structure, conductivity, and boiling and melting points of ionic compounds. Now we're going to do the same thing for the covalent network and for the molecular compounds as well. So the structure of a molecular compound. The key thing is a molecular compound is made up of individual molecules. So molecular compounds are made up of individual molecules. The word molecular, molecule, they sound similar, so connect them. So each individual molecule is going to be made up of nonmetals that are held together by strong covalent bonds. So what you're looking at is an individual molecule of water. We have oxygen and two hydrogens. Those nonmetals are connected by those strong covalent bonds. But what happens is the different molecules interact with each other and their environment using what are called weak intermolecular forces. So towards the end of this unit, we'll look at the different types of intermolecular forces and how to identify them. But for right now, you should know that molecular compounds, their structure, they're individual molecules that are held together with covalent bonds, but the individual molecules interact with each other and their environment using what are called weak intermolecular forces. So it doesn't take a lot of energy to disrupt the weak intermolecular forces that hold all of the molecules that are interacting with each other. So molecular compounds generally have low melting points and low boiling points. So it doesn't take a lot of energy to disrupt those weak intermolecular forces between them. So as a result, they generally have low melting points and low boiling points. A lot of molecular compounds are going to exist as liquids or gases at room temperature for this reason. So think of water, liquid at room temperature, CO2, it's a gas at room temperature. It's easy to disrupt these weak intermolecular forces. So molecular compounds, they have low melting points and low boiling points. So generally at room temperature, a lot of them are going to be gases and liquids, but some also are still going to be solids. So for example, table sugar, that's a solid at room temperature, paraffin wax, that's a solid, but a lot of them end up being gases or liquids. All right, so next thing is molecular compounds contain nonmetals that do not lose their electrons easily. There's no ions involved, there's no charged particles that can move around freely. So as a result, we're going to classify them as generally being non-conductive. They're not generally going to conduct electricity. So as a result, they're good insulators. So for example, rubber is a molecular compound. A wire is going to be covered in rubber since it's going to be non-conductive. All right, next thing is for a covalent network compound. A covalent network compound are giant molecules arranged in a 3D crystal kind of structure. There's a certain repeating pattern to them. So covalent network compounds are either going to be elemental or pure carbon, like C diamond or C graphite, or something containing a metalloid, but you have these kind of molecules that kind of have this repeating pattern to them. So elemental carbon is what's called an allotrope. You have C diamond and C graphite. They're both only made up of carbon atoms, but you have these two different formats based off of kind of how the geometric structure is arranged. But a key thing when identifying something as being covalent network, one thing that you could look for is elemental carbon or pure carbon. It's when carbon is by itself, and generally the two ways that you're going to see it as being either C diamond or C graphite. All right, so for a covalent network compound, the covalent bonds that hold them together are very strong. So as a result, they have really high melting points and boiling points. So you could see silicon dioxide, you could see diamond, both of them have really, really high melting points. So covalent networks, those covalent bonds are very strong. So as a result, it's hard to disrupt them, and they're generally going to be solids at room temperature. Covalent network compounds have a strong hold on their electrons. There's no charged particles that can move around freely. So as a result, we're going to see that they're generally going to be non-conductive. All right, so answer the following 4 check for understanding questions. For number 1, it says which of the following would be classified as a covalent network solid. What I would do is next to each option, write what it is. So first one is sodium chloride, that's ionic, it's a metal nonmetal. The next one is molecular because it's just made up of nonmetals. C is covalent network because it has a metalloid in it. And then D is just made up of nonmetals, so it's molecular. 2 says which of the following would have the lowest melting point. I would make a note to myself that I'm looking for something that is molecular. So the option A is molecular because it's just made up of nonmetals. B and C are both covalent network because they're pure carbon, elemental carbon. And then D is ionic because it's a metal and a nonmetal. The answer for 3 would be both B and C. Anything that contains a covalent bond is going to be generally non-conductive, so covalent network and molecular. Finally, last one, which type of compound is made up of individual molecules held together by weak intermolecular forces? Once we talk about molecules, intermolecular forces, we're looking for something that is molecular. Molecular compounds, their structure is that they're made up of individual molecules. So now to kind of summarize what we've looked at so far. We've looked at ionic compounds, covalent network, and molecular. when you're kind of learning their properties, sometimes it's helpful to group them. So for example, ionic compounds, just ionic bonds, but covalent network and molecular both have covalent bonds that are holding them together. You should be able to identify them. So ionic is metal-nonmetal, metal-poly, poly-nonmetal, poly-poly. Covalent network either contains a metalloid or is that elemental or pure carbon, and a molecular compound is just made up of nonmetals. In terms of their melting boiling points, ionic and covalent network have high melting points, high boiling points. They're generally solids at room temperature, whereas molecular compounds have those low melting points, low boiling points because of those weak intermolecular forces that they're interacting with and kind of their environment with as well. In terms of conductivity, ionic compounds will conduct in the liquid and aqueous states, but not the solid state, whereas covalent network and molecular are generally non-conductive. Ionic and covalent network both have lattice structures. There's a certain repeating pattern, whereas molecular compounds are just made up of individual molecules. There is a fourth type of compound that we'll add, which is metallic, but at this point we've just looked at ionic, covalent network, and molecular.